The Earth's crust is supported by separate plates called tectonic plates. They are always moving, but at a very slow rate of 2 centimeters per year. This movement is due to the Earth's mantle, which is soft, solid rock located under these plates. Because of the consistency of the mantle, the tectonic plates slowly drift atop it. There are 3 different types of plate boundaries: convergent, in which plates move towards each other; divergent, in which plates move away from each other; and transform, in which plates slide past each other. The Mesosaurus was an ancient creature which lived during the early Permian period, or about 299 to 270 million years ago. According to paleontologists, unearthed what may be the longest known Mesosaurs. This text also states, these creatures were the first known aquatic reptiles, having apparently returned to an aquatic lifestyle from more terrestrial ancestors. Their long-snouted skull is composed of very thin cranial bones, and it bears numerous needle-like marginal teeth. Mesosaur autogeny is well documented, with body lengths ranging from 10 to 12 centimeters in hatchlings to 80 or 90 centimeters in young adults. The average Mesosaurus also had a long body and tail, but are still medium-sized. However, scientists discovered Mesosaurus fossils on the South American plate and the African plate, which are both extremely far apart from each other. So how did these fossils get so far apart? I believe that the boundary between the South American plate and the African plate is divergent. My first piece of evidence on why the fossils got so far apart is that Alfred Wegener found specific rocks that were found in mountain ranges on the southwestern coast of Africa and the eastern coast of South America. This is supported by a continental puzzle and would explain the gap between the fossils, because if the rocks match, they might have been part of the same mountain a long time ago. My second piece of evidence on why the Mesosaurus fossils got so far apart is that the coastlines of the southwestern coast of Africa and the eastern coast of South America match up, along with all the other continents. This was also supported by Alfred Wegener according to a continental puzzle. This text says, he argued that the continents had all been together in one large supercontinent, which he named Pangaea. However, Alfred Wegener also stated that it might have taken over hundreds of millions of years for Pangaea to split into the continents we know today. My third piece of evidence on how the fossils got so far apart is that when the boundary between 2 plates is divergent and they move away from each other, magma fills in the gap. But if ocean water is above this boundary, it quickly cools the rising magma, turning it into a mid-ocean ridge. However, if you look in between South America and Africa, you will find the Mid-Atlantic Ridge. The Mid-Atlantic Ridge, too, is a mid-ocean ridge, which means that it was also formed by 2 plates moving away from each other. My final piece of evidence on how these fossils got so far apart is that in Plate Motion Lesson 1.4, the captions under a picture state that now South America and Africa are around 4,000 kilometers apart. By doing the math and translating 1 kilometer into 100,000 centimeters, we can multiply 4,000 by 100,000. This shows us that South America and Africa are 400 million centimeters apart. However, since plates only move 2 centimeters a year, we can estimate that South America and Africa took around 200 million years to separate, which we know is accurate because Alfred Wegener stated that it might have taken hundreds of millions of years for Pangaea to split.